In this video, we shall find the expectation and variance of the normal distribution. Of course, for a continuous distribution. For more on this topic, you need to subscribe to this channel. Of course, for the expectation of x, this is our PDF. So the expectation for a continuous distribution, the expectation of x is equal to the integral from minus infinity to infinity x multiplied by f of x dx. So this becomes the expectation of x, where this is the PDF. So all we need to do is to put the PDF into this. The next thing to do, we say the expectation of x is equal to the integral of x multiplied by the whole of this, which is 1 all over sigma square root of 2 pi exponential negative x minus mu raised to the power of 2 all over 2 sigma squared dx. So the next thing to do, we can bring out this, we can factor this out. So factoring that out, we can write our expected value of x to be equal to 1 all over sigma square root of 2 pi into x multiplied by exponential negative x minus mu raised to the power of 2 all over 2 sigma dx. Of course, we can say let t, using change of variable, let t be equal to x minus mu all over sigma. It implies that x minus mu is equal to sigma t. It also implies that x is equal to mu plus sigma t. So the x will be equal to, of course, this will give us 0, the t. So we use this change of variable to put inside here our expected value of x. Our expected value of x will now import this to this point. So we have 1 all over sigma square root of 2 pi integral of from minus infinity to infinity. This x becomes mu plus sigma t. Then exponential, we can write it as negative 1 all over 2 t squared dt. Because we have now imputed every value, the x is now this dt. So we have sigma dt. So we have changed the x to be the whole of this, which is this. The next thing to do is to multiply this by this and this by this. Of course, this sigma will come over here to give us sigma all over sigma square root of 2 pi integral of this will multiply this to give us mu e negative 1 all over 2 t squared plus this will multiply this to give us sigma t exponential negative 1 all over 2 t squared dt. So this is our expected value of x. Of course, now this function, this will cancel this. So we'll be left with 1 all over this. And we'll use it to multiply this function and also this function. So we'll come over to this other side. So if we bring down this, we separate this, we'll get our expected value of x to be equal to the integral from negative infinity to infinity mu all over, because this will come over here, square root of 2 pi exponential negative 1 all over 2 t squared dt plus the other part negative infinity to infinity. We have this part with this. So we have sigma t all over square root of 2 pi exponential negative 1 all over 2 t squared dt. Of course, mu can come out to give us mu into 1 all over square root of 2 pi exponential negative 1 all over 2 t squared dt plus we have negative infinity to infinity sigma t all over square root of 2 pi exponential 1 all over 2 t squared dt. So this is simple and easy. From here, we've obtained this. So this is our expected value of x. Of course, the whole of this is equal to 1, while the whole of this is 0. So we have our expected value of x to be equal to mu multiplied by 1 plus 0, which is equal to mu. Of course, our expected value of x is equal to mu. So we have succeeded. From here, we multiply this by this by this to get this. So from here, we obtain this. And the whole of this gives us 0. While the whole of this will give us a function 1. This is equal to 0. So mu multiplied by 1 plus 0 is mu. So the expectation, which is ex, is equal to mu. So our expected value of x for the normal distribution, for the continuous normal distribution, is equal to mu. Is equal to mu. So this is how we can obtain the mean or the expectation for the normal distribution of a continuous distribution. For more on this topic, you need to subscribe to this channel. The next is to obtain the variance. The next is to obtain the variance.